don't like talking over people. Solving systems of equations is something that each and every one of you guys have done in the past, whether it was a little bit, last year I think there was like 1 or 2 geometry problems we had that you had to do a system of equations, or more often than not, it was back in Algebra 1. So it's been a little bit of time. One of the reasons why I bring up systems of equations is because in this class we do so many things of manipulating equations. We change their form, we do scalars, we add them, we subtract them, we mess around with them, we look at the intersections, we look whether or not they intersect. We look at their graphs. We do so many things with equations, dealing with systems today, and then tomorrow we'll deal with systems of inequalities with a new way of graphing that I'll show you. It's a really good way to get your minds back into what does it look like to work with equations in algebra. Because after that, when we get running into the quadratics, we just go, okay? So systems of equations, remember, when you're solving a system of equation, what you really are doing is you're looking for the intersection that one doesn't work. It's weird. You're looking for, when you're dealing with the system, you're looking for the intersection of 2 lines. And the way that 2 lines can intersect, there's 3 possible things that can happen. 2 lines can intersect at 1 spot. That means that there is 1 solution. Two lines could not intersect, meaning that they are parallel, very good, or no solution, good. 2 lines can be parallel, so they have no solution.
I almost had the dumbest.
And then what's the other one? They're on the same line. So if they have the same line, sometimes you get the equation that's written out the same way, which is a different scalar. If they're the same line, they have infinite solutions. Okay? They have infinite number of solutions. So they have every single ordered pair is a solution. So what we're going to look at today is 2 equations, 2 variables. Later on in the school year, when we have a little bit more time, we'll come back and we'll deal with 3 equations, 3 variables, which is 3-dimensional space. We might even go to 4D, 5D, and see how we can do with solving systems equations with multiple variables. It's quite interesting. You don't sit, yeah.
Yay!
Thank you. I can always count on you. So here's what happens. We're going to look at a couple of different methods to solve systems. And there is no right or wrong way. There's just easier and more complex ways. And each scenario for dealing with a system of equation is always different. For example, the 3 methods that I look at, well, basically 4 if you want to argue semantics. The 4 ways that you can solve systems is, well, first of all, you can use what's called substitution. Yeah. You can do elimination, or what's called linear combination. Each one of these methods is valid in its own right. It's always dependent upon you to make the decision as to how you want to solve it. There is no right or wrong way. I know that in years past you guys were told, use substitution, use addition, use subtraction, use linear combination. For me, I don't care. You have the choice to what works best for you. Some people think one way is easier and they stick with it. That's fine. There's nothing wrong with it. But what I'm going to show you is that there's always a time and a place that one of these works best. For example, substitution. If I'm going to use substitution to solve a system of equations, I want to have a variable ready to be by itself. So Using substitution, I would look for, is a variable by itself or can be quickly. So if I'm looking at the one up above it, see how it's x plus 2y equals 2? I can get x by itself in one step and use substitution. That's what I mean by can you get it by itself quickly, as opposed to solving it, dividing, and getting a fraction and all that. Sometimes it's not as clean to go that route. Elimination. What I mean by elimination is I can add the two equations together or subtract the two equations together. When I do that, I'm going to use it only when, this is for adding or subtracting. I can add the two equations together if they have the same coefficient. What's coefficient again? Yeah, the number before. With same coefficient with opposite signs. So example, just if I throw this here, see how it's 3x and negative 3x? If I add those two equations together, the x's go away, and I'm just left with just y. Does that make sense? That's the scenario that I would use addition. Subtraction is just the opposite. Same coefficient with the same sign. 3x and 3x. If I subtract those two, the 3x's go away.
Yay.
Personally, I tend to shy away from subtraction. The reason is because if you have a whole bunch of negative values, you guys tend to screw up subtracting negatives. It's inherent. It's not a concept that you guys ever really fully grasp in why things change. It's just a mistake that I know you guys make. Just be careful when you use subtraction. And then last but not least, the linear combination is basically when all else fails. When all else fails, what you're doing with linear combination, you're going to be multiplying by some scalar. What I mean by that is you're going to multiply the entire equation by some value. You're going to turn it into an elimination problem.
Sounds fun.
Okay? So you basically turn into one of those. Okay. I got a couple examples of all of it, so you'll see how it goes. I know that you guys have done this. It's just a matter of remembering. That's all. Oh, but congrats though for winning last night. And you were saying you were worried because you didn't know how it was going to be because they were all new.
I was excited.
Well, I know, but you were worried because they were all there. You said it was going to be slower.
Oh, yeah.
So let's do a problem.
Do we have to?
Yeah, that's fun. Let's do this. I think most of you guys probably had this one already written down. We have 3x plus 4 is negative 4, and x plus 2y is 2. So, what method do you think would be the easiest to do?
Math.
Okay, narrow that down a little bit. Don't go algebra. Substitution, yeah. I would use substitution in this one. And the reason I'm using substitution is that I can just go x is 2 minus 2y. One step, I get a variable already alone by itself. I can now take this value of x and just substitute into here. And then I have one equation with one variable.
Oh.
And I get 3.
I was so confused.
Remember how we were talking yesterday about how it's very easy to write wrong numbers and stuff down because the problems get so garbled up in the book? This is the section that it happens a lot because they're so closely written together. Now what do you do? Solve y, distribute the thingy, yes. Distribute out. So 6 minus 6y plus 4y is negative 4. With any luck, you get 5.
Holy.
Oh, I see one.
For shame. And it's, like I said, this is the other good reason why we do these problems, because it gets you guys out of summer mode and back into the idea of math. So now what do I do with the 5?
Wait, you substituted it.
Never mind, I got you.
Substituted it into find the value of x.
Correct. And I just substitute back in. So x is going to wind up equaling 2 minus 2 times 5. And we get negative 8. Therefore, I have what's called now a solution set. My ordered pairs, if you will. My ordered pair of where these two lines intersect is at negative 8 and 5. I would appreciate if you wrote out your ordered pairs as the solution. That's technically the right way to do it. Okay.
Yay!
Not scary? Okay. These are boring. Okay? That's easy. Now what do you want to do?
Elimination.
If I want to use elimination, if I'm going to go straight to elimination, I want to have same coefficients on both of them. I don't, but I know what you're thinking. You're going to have to use elimination, but technically we have to do some linear combination first. Okay? Does it matter which one you get rid of, x's or y's? No, it really doesn't. It makes no difference. What do you want to get rid of, x or y? X, okay. In order to get rid of x, and I agree with you, getting rid of the x is one less step than getting rid of y. The reason is, I can multiply just the top equation by 2, and it becomes 4x. If I wanted to get rid of y, I'd have to both multiply the top and the bottom to get a multiple of 4 and 5. Does that make sense?
Yes, sir.
I'm trying to find my easy way out. I'm trying to find the path of least resistance. It sounded French. What do we want to multiply the top one by?
2.
Rub my mustache. Get your baguette.
2.
I think we're getting borderline racist here.
No. I've been to France. I bought a baguette. I can do these things. Now what do you do? Distribute first. Now, what I'm going to do here is distribute out. I'm just going to rewrite it right below this. Little tip, when you're writing out systems of equations, when you're going to solve them and all that, space it out a little bit. Because I kind of oversimplify this because I know what you guys are going to make a mistake at. You're going to garble something up. Just split it up. You know you have to subtract everything. 4x minus 4x. Negative 5y minus negative 8y. 8 minus 26. What I'm doing here is just breaking it into the 3 simple subtraction problems. Does it take an extra step to do something like that? Yes. Do you really, really have to? No. It's habit for me to do that because I know that you guys will skip that sign in the middle. Because it happens. Okay. X's are eliminated. We wind up with negative 5 plus 8. So we get 3. Then we get negative 18. Got how to draw an 8 for a second. So what's y? Very good. What?
Yay.
And once again, we just take it back into one of the equations to solve back out. Remember, it does not matter which equation you choose to resubstitute back in. It really doesn't. We'll go with the second one this time. 4x minus 5 times negative 6 is 8. 4x plus 30 . And I'm going to get a fraction of negative 11 over 2. I still have not got the emulator software, to work on my computer, but I do want to show you guys 2 ways you can put fractions into this calculator. If you type just directly into the calculator, negative 22 divided by 4, you're going to get negative 5.5. Well, to me, decimals don't really exist unless I say round to the nearest, whatever. I like fractions. These calculators will convert. Oh, sorry for using way. Will convert the fraction for you by hitting math, enter, enter. Or if you automatically type this in with a fraction bar by doing alpha y equals. Alpha is the green button, y equals is the top left. Hit enter, and just type in the fraction right away, negative 22, use the down arrow, over 4. It'll spit it out in terms of a fraction. It does the work for you. There's a couple of ways to do it, okay? It will do that. Unfortunately, this calculator doesn't do those square roots. You know, square root of 12, it's not going to say that it's 2 root 3. But we'll worry about those things when that time comes. That's me.
Why did you make it positive 8 now?
Oh, negative 5 minus negative 8, same change opposite?
Oh, so it's always negative.
Not necessarily. It was just so the problem was.
No, like it's always something minus something, and then you plug it in and it's negative, negative, positive. Even on the other side too.
Yeah, it was 8 minus 26, I got negative. Yeah. Yes, sir.
I figured out how to get it into a fraction. You go up to mode, or you go to mode and you go down to
Math print?
answers. No, it'll say answers, auto, decimal, fraction.
Okay.
Go with the fraction.
Oh, okay. I didn't realize the setting worked. It doesn't work. I don't think it works all the time though. That's why I know that you can. Usually, if you put it in the fraction start, it'll pop it out with the fraction. So, yes. That was what we did there was linear combination to make it elimination. Okay. And you probably will start to recognize what you have to do things. What we did there is we multiplied by a scalar. We multiplied by some multiple. You do this.
You're pretty needy.
You guys multiply the top by 5, the bottom one by 2. Okay. All right. Could I just do this and say negative x plus y is 3, so y is x plus 3, and just go and be done?
What?
No,
Wait. What?
I see right there.
Now, and that's okay. Here's the thing.
Aw, man. Thank you. Anyway, so hey guys, for all of you that did that, where you just multiplied the scalar and did all that, there's nothing wrong with that. No, there's not. There's nothing wrong with it. The reason that I'm saying that I recognize I've got a quick scalar of 5 thrown in there is just quicker. You're still going to get the exact same answer if you do it right, but it should still work. That's the only reason why I show you guys this one, because a lot of times you guys overthink. Take a look and see if there's a simpler way to do something.
I thought I was.
It's okay, Jonathan, it's all right, man. There's nothing wrong with it. Nothing wrong with it. When you substitute through that, just to be on the safe side, so we got 2x plus 3x plus 9 is -1. So what is that, 9x, you get 5, x is -2. So y is 1. You get the exact same answer, but you see by doing it my way, it's just a little bit quicker. That's all. There's nothing wrong with it. Seriously, there's nothing wrong with it, guys. I just like to annoy you sometimes like that. That's all. They give you some homework problems because I think we're okay.
No.
This is section 3.2. No, it's 2 something. I forgot what page number it was. Let me look.
I do it off the internet. It's all right there.
It's on page 153. I'd like you to do numbers 35 through 40 as well as 49. What's that? These are all systems. Yep. These are all systems of equations. Tomorrow we will talk about systems of inequalities, which is basically graphing again. Okay? Then that way next Tuesday, probably Tuesday, Wednesday, and most of Thursday, we will spend on what's called linear combination, which is word problems. The algebra 2 word problems we try to hit you right off the bat with some fancy ones. They're not as scary, but it's a whole nother thought level on how to interpret a problem. It takes a couple of days to get it down, or get it down pat. So my best guess at this point then, by inequalities tomorrow, easy. Tuesday, Wednesday, finishing up the linear combination, reviewing it, everything. Thursday, we'll probably have a brief test-ish thing a week from tomorrow. Yes, ma'am. There should be one in the back cabinet. Help yourself. You're welcome. All right? Get it cracking.
What do we?